All right, you've made it to 3.3.1, and this one is where students will, in writing, use graphs to validate algebraic solutions and to explore extraneous solutions using sequential math steps. So let's think about things we've learned now, right? So we've learned that when we have one equation, solutions are x-intercepts. When we have two equations, solutions are where they meet, okay? So in this case, we're going to mix those two things together a little bit. So let me show you some information on this problem first. All right, so obviously we didn't do this problem. You actually did, you just didn't do it in this form, but that's okay. And so consider the question as you solve the equation, the square root of 2x plus 3 equals x by completing parts A through D. All right, so let's go ahead. The first one says use algebra to solve it. Cool. So let's go down here. We got the square root of 2x plus 3 equals x. And it wants us to solve using algebra. And what that means is it wants us to tell me what x equals. So what does x equal? Well, no problem. So if you don't know how to get rid of a square root, the opposite of square rooting is squaring, okay? The opposite of square rooting is squaring. So the first thing I'm going to do right here is I'm going to square this whole side. You can only do it if it's a whole side. But if I do it on one side to keep this equal, like a balance beam, we also do it on this side. And what the square root and the square does, it completely cancels each other out, okay? It's like saying, well, if I do 2 squared, I equal 4. But if I take the square root of 4, well, I'm right back to 2, right? I'm right back to where I started. So this just canceled out. So here we go. That's all I got left. 2x plus 3 equals x squared. Okay, so I'm looking at this and I'm going, well, the only way to solve a square is to square root it, but I just got rid of a square root, so I don't think that's a solution. So instead, I'm going to look at this and be like, oh, I know what this is. It's a quadratic. Okay, it's a quadratic, and I have tools to solve a quadratic. Those tools are, I can either factor, I could graph it and look for the x-intercepts, I could use the quadratic formula. Any of those are valid. So first things first, I got to make this all on one side. Okay, I got to get it all on one side. So I'm going to go ahead and I'm going to start right here and I'm going to do 2x and minus 2x here. So I got 3 left over here. And then I got x squared minus 2x. Still want to move this 3 too. And you're asking me, why did I move it to the right and not the left? Well, I'm going to tell you the reason I moved it to the right and not the left is so I didn't have a negative x squared. But in all reality, none of that matters. Okay? It doesn't matter which way you go. So let's get that 3 out of there. Now I have 0 left over here, right? Nothing left. And I have x squared minus 2x minus 3. All right, and I'm going to factor this. And now factoring is something we'll go over again in the future. However, it is something you should have learned in Integrated Math 2. If you don't know how to factor, we will touch it more. We will touch it more. Do not worry. I like to use this method. It is called the X-puzzle method. And that's where I'm going to take the C term, right? The term all by itself. The C I'm going to put in the top. Okay? And I'm going to take the B term and put it down here. All right, bam. So now I have to ask myself this really awesome question, which is, what two numbers multiply to negative 3, but add to negative 2? Well, I only know 2 numbers, right? So the factors of 3 are 1 times 3. That's all I know. So I know I'm going to be a 3 and I'm going to be a 1. Now, if I add 3 plus 1, I get 4, right? And if I multiply 3 times 1, I get positive 2. So one of these has to be negative, right? Because the only way to get a negative number from multiplication is to have one negative. And since this is also negative, I know that my bigger number is negative. And if you do not know these rules, they are on a poster in my classroom. Find those rules, okay? Find those rules. All right, so now I have my 2 solutions, right? So with that being said, what I'm going to do is I'm going to write those 2 solutions. 0 equals x minus 3 or x plus 1. And then I can use what's called the zero product property to separate those, right? So now I have x minus 3 equals 0, or x plus 1 equals 0. And I just simply solve for x plus 3 plus 3. I'm going to move the solution up here, guys, okay? So x equals 3. And this one minus 1. So x equals negative 1. Okay, so what this is saying is that I have a solution where x equals 3 or x equals 1. So now I need to ask myself, how do I find the y coordinate? So let me go ahead and clean this board just a little bit, okay? Just a little bit. Give me a just a little clean here. Okay. All right. So now to find the y coordinate, I need to go back here and I need to look at the fact that I have something equaling something. Well, in all reality, what I have is two equations. Y equals the square root of 2x plus 3 and y equals x. I just divided those into two equations. All right, so let's find the y coordinates. I'm going to put the 3 back in here. If I put a 3 in for x, y equals 3, right? So that, therefore, this one says 3 comma 3 is a solution. And the same thing with the negative 1. If I put the negative 1 in here for the x or use substitution, I get the same thing. I get negative 1 comma negative 1. Now, I also need to look at it for this equation too, but first let's hold off really quick. So the question's asking how many solutions did I come up with? Well, I came up with 2 solutions, right? 3 and negative 1, or these points. These are the points I came up with. So the next thing I want to do, the next question says, in thinking about square root of 2x plus 3 equals x, Miranda writes down y equals this and y equals that, which is what I just did. How many solutions does this equation have? Oh, here we go. Now we're talking about that one equation solutions, right? Well, how many times will this hit the x-axis? How many times will this hit the x-axis? So I want you to go ahead and I want you to graph these in your calculator and then come back to the second video. And if this is giving you any insight to solving this problem, go ahead and try the next ones without the video.